Alright, welcome back all to the second problem of the three that I'll be doing for you guys here. So this is number 15 in your practice test. Once again, if you didn't see the explanation in the first video, I was originally going to write out the solution to these and just post it on Canvas, but I felt that it would be better for me to work these out and talk through it in this sort of environment. So that's what I'm going to be doing. So number 15 gives us what's called the ideal gas law, which essentially relates pressure and volume to a temperature with a couple of constants mixed in, which is this R, this is called the gas constant, and then N, which is the amount of moles that you're working with, which is the amount of moles that you have. And we're given the value of these two constants in the problem, okay? Note that N is a constant indeed. So the derivative of both of these with respect to T would just be 0, so we won't be considering that. P, we're given the pressure is at 7 atm, and that it's increasing, I should say, at a rate of 0.10 atm per minute, okay? Another important fact is that we have the volume that we have at this point is 10 liters, and the volume is decreasing, okay? So there's important words there to keep track of, increasing and decreasing. Since this one was increasing, we had to be positive, but since the derivative with respect to V, the volume, is decreasing, we need to put a negative 0.15 liters per minute on that, okay? So then the question asks us to find what rate is the temperature changing, right? Which the temperature is changing at is dt over d of big T over d of little t, right? So we need to use this, or we want to find this using all of the information we're given here, right? So let's just go ahead and take, right, we have this one equation, and it seems like we can probably plug in a lot. Let's just take this equation that we're given and do the derivative, okay? So I'm going to write it real quick. PV equals NRT. Now, keep in mind, remember, of course, T is a function of T. I'll write it like that. So that means that its derivative is not 0, right? P is also a function of T, right? That's why we have the rate, so we need to consider that. And V is also a function of T, because it also has a change. It has some sort of rate of change. Right, we have on this side, right, we just have T and then R and N are constants, as we've said. So there's not going to be any issue there, right? Remember that if I am taking the derivative of a constant times a function, it is going to be the same thing as the constant times the derivative of that function, or c times f prime of x. Okay? So these are both constants, so it doesn't affect the t. However, since p and v are multiplying on the left here, we're going to be needing to use product rule, right? Because these are both functions of t. Okay? So, as a reminder, product rule says that if I have, and I'll write it in t just so it won't be too confusing, if I have the derivative with respect to t of f times g, this is the same thing as f times g prime plus f prime times g. Okay? So in this case, I'm going to let f be equal to p and g be equal to v. Which, of course, that automatically leads us to conclude that f prime, sorry, I put the prime there in accident, just ignore that one, it should only be here. F prime is equal to dp over dt, right? It's just the derivative of p with respect to t. And g prime is dv over dt, right? The derivative of v with respect to t. And so now we're going to take all this information and plug it in here, and that will be the left side of this equation after we take the derivative. So I'm getting that P times V equals, right, now as we said, we have a constant, which is n times r, and then we do the derivative of t, which is the dt over dt that we want. Of course, from here, it's really easy for us to solve for the value we want. And so we have that dt over dt is equal to p times dv over dt plus dp over dt times v over n times r. Okay, so that's just simple division there. And then, of course, we have every one of these numbers. So we just plug in respectively, right? So we have that p is 7, dv over dt is negative 0.15, dp over dt is 0.1, and v is 10 liters, and that's all divided by n times r, which is going to be 10 times 0.00821. Okay? And this is multiplying 0.0821. Okay? So, what's going to happen in this case, right, is I just plug that in. I mean, a lot of times we may not be able to calculate that very well because you can't use calculators during your test, but that's how you get the general answer. And if you were to plug in the numbers and check it, you should be getting negative 0.061, and that's in terms of temperature. And the units here are probably going to reflect Celsius or Kelvin, which this isn't a big deal, but just to kind of make sure we're keeping with everything. So this would be negative 0.061 Kelvin per minute. Okay, so not a huge drop per minute, but still pretty, you know, it's significant in some way. So that's the answer. All right. Well, I hope that helped. Thank you guys so much for watching.